By using a balancing method, a student places a meter rule on the pivot. Then he places a load P, which is labeled as 1.5 on the meter rule at 90 centimeter mark, and he keep P at 90 centimeter, and he just adjusted the position on the pivot so that it is near to possible being balanced. Table 1.1, he records the distance A from 50 centimeter to the pivot, and B is there, the distance between the load and the pivot. The student repeat the procedure using different loads 1.2, 1, 0.8, and 0.5. Determine the value for B. How we can determine the value for B? If he record because in table 1.1 he record the distance A from 50 centimeter, which is marked on from a 50 centimeter mark to the pivot. So pivot is at 50 centimeter mark and he measure A. And then what about B? If P is at 90 mark and the pivot is at, if this the load is there, the center of the mass of the meter rule is at 50 mark and the load P is placed at 90 mark. And A is a distance which is how much? 23.1. So this A is 23.1 because from 50 to 90, the total distance is 40. So this total distance is 40. And out of this 40, A is 23.1. So how much is B? To get this value of the B, we subtract 40 minus 23.1. This will give us the value of B, which is 16.9. So this B will be equal to 16.9. So we have to complete the table first. And then so this will be 16.9. And then A divided by B, so 23.1 divided by 16.9, that will give us 1.37. Then we have to plot a graph for weight on y-axis and 1 over b on x-axis. Do not begin, you do not need to begin your axes at the origin, which is, so we don't have to include 0, 0. So we have to plot a graph between P and A over B. So I'm writing the value P is equals to 1.5, 1.2, 1.0, 0.8, 0.5, and 1 over B, 1.37. That was the first value. 1.13, 0.900 or 0.9, 0.72, 4, and then 0.455. Now we have to plot a graph. P is on y-axis and A over B on x-axis. So P is on y-axis and A over B on x-axis. It's a ratio, it does not have any unit. For P, we don't have to start from origin. Our minimum value is 0.5 and maximum is 1.5. So example, if I start with say 0.5, 0.6, 7, 0.8, 9, and 1.0, I will not get. But if I select 2 boxes, 10 boxes equal to 0.2, so this will be 0.7, this will be 0.9, this will be 1.1, this one is 1.3, and then 1.5. So I'll get the values. And then for A over B, the minimum value is 0.4 and the maximum value is 1.3. So if I start with 0.4, then 0.5, 0.6, I won't get it, like the scale will not be complete. So if it is 0.6, 0.8, 1.0, 1.2, 1.4, and then 1.6. Now we have the values when the P is equals to 1.5. This is 1.37. So 1.37 and 1.5, I'll write the numbers in between. This will be 0.5, 0.7, 0.9, 1.1, 1, 2, 3, 4, 5, 1.3 and 1, 2, 3, 4, 5. So 1.5 will be there. Now 1.5 and 1.37. So 1.5 and 1.3, each box is equals to 0.2. So 1.32, 1.36, 1.34, 36, and 38. So between them will be 37. So this will be here. The first point. This will be the first point. Then 1.2 and 1.13. 1.2 for x-axis between this is 0.6, 0.8, 1.0, 1.2, 1.4. So 1.2 and 1.13. So 1.2 is this value, and then 1.13. So 1.1, this is 1.1. So 1.12 and 1.14. So this will be between them. So between them, then 1.0 and 0.9. So 0.9 and 1.0. Then 0.8 and 0.72. 0.8, this was 0.8, and 0.7 is this, 0.72 will be. Then we have 0.72, yes. And then we have 0.5 and 0.45. 0.5 and 0.45. So 0.42, 0.44, 0.45 will be here. So the line that we'll draw best fit straight line, use thin lines as possible. When you're joining the points, use thin line. And this is the best fit straight line. As you can see, I have 1 point above, 1 point below. So this was a graph between the P and 1 over A. The next part, determine the gradient. So how to determine the gradient? You have to show your working, like how you determine the gradient. So you first mark 2 points and try to increase the distance between the 2 points when you determine the gradient. So example, like about 5 centimeter distance should be there between the 2 points for accurate result. So if this one, the first value on x-axis, y-axis is y1, the first value on x-axis, like this one is the first point I marked. The first point on x-axis is equal to x1. The second point is x2. The first point on y-axis is y1, and the second point will be y2. So I have the value y1 equal to how much? 0.7. Y2 is how much? 1.3. X1 is 0.6264. And x2 is how much? 1.2. So the formula for the gradient, it is y2 minus y1 over x2 minus x1. That's a formula you have to remember. So it is 1.3 minus 0.7 divided by 1.2 minus 0.64. So 1.3 minus 0.7 equal to 0.6, and 1.2 minus 0.64 equal to 0.56. So 0.6 divided by 0.56 is 1.07. So that is the value for the gradient. What we write here, the value for the gradient to be 1.07. And you have to show clearly on the graph, like the line which I draw on x-axis and y-axis, you have to draw those lines. Then they mention gradient is numerically equal to weight of the rule. So what is the value of the gradient? Same as the weight. So that is 1.07. But why is of 2 marks? 1 mark is for writing the unit. And why this part is of 2 marks? 1 mark is for showing the working on the graph. Like we draw the x on x-axis and y-axis, the points. And 1 mark is for answer. For this one, 1 mark is for just writing the same number. And 1 mark is for the unit. And student, assume that the center of the mass of a meter rule is at 50 centimeter. Explain briefly how would you find as accurately as possible the position of center of the mass. So how we determine the position of the center of the mass for any object. So we will pivot at different position. So we'll pivot from different position, the point where it is balanced is center of the mass of the object. So any object I want to determine the center of the mass, this is always the way. Like we pivot from different locations, position where it is balanced, that is a pivot. Briefly state the main difficulty that you would have when you're carrying out this experiment. So what is the main difficulty? The main difficulty, difficult to balance a meter rule when the load is placed on it. That is the main difficulty. So this is always a difficult task to balance a meter rule when the load is placed on the meter rule.